Now we continuing with the third lecture of the unit S block elements. Question is, give preparation and uses of NaOH. We have Kastner Kellner process. In this method, NaCl is electrolyzed in a 3-compartment cell. The outer compartment they contain the dilute solution of NaCl, while the central compartment contains the aqueous very dilute solution of NaOH. In the outer compartment we are having graphite electrodes which act as anode in the outer compartment, and a mercury layer is drawn at the bottom of the outer compartment, which act as cathode in the outer compartment, and mercury layer act as anode in the central compartment. So this is a 3-compartment cell. In outer compartment NaCl get electrolyzed and sodium combines with the mercury of the mercury layer at cathode, produces sodium amalgam. This amalgam is brought in the central column with the help of the pivoted end and wheel arrangement, eccentric wheel arrangement, and where it combines with water and raises the concentration of NaOH in the central compartment, which was very less in the beginning. So after the complete process, it will be around about 90 to 99% NaOH. At that time this electrolysis will be stopped. So what is done in this case, we are having a 3-compartment cell. These are the slate partitions which are dividing one compartment into 2 compartments. Here we are having some groups to rest these slate partitions. At the bottom we are having mercury layer in the outer compartments which act as cathode in the outer compartment, and this mercury layer act as anode in the central compartment. Now what we are having in the outer compartment, we are having dilute solution of NaCl in both outer compartments, and we have dilute NaOH solution in the central compartment. Outer compartment they are fitted with 2 metal cathodes, anodes, which are the negative, these are the having the positive charge on them. In the central compartment we have number of rods of graphite which are acting as anode here. From the outer compartment chlorine gas is produced. From the central compartment hydrogen gas is produced. So these are the compartment of reactions. Here we have eccentric wheel and pivoted end which is having a screw-like arrangement. It can be lifted up, it can be brought down by making the movement of the screw. Wheel will have to bring this sodium amalgam to this chamber, this to this chamber. So now reactions in the outer compartment. NaCl get ionized to produce Na positive plus Cl negative ion. At anode 2Cl negative moving to give chlorine gas. It escapes out from this rod, and at cathode, that is mercury layer in the outer compartment. Here sodium takes up electron and combines with mercury to give you sodium amalgam. It is brought in the central compartment to reaction in central compartment. Here NaHG combines with water of the dilute NaOH, producing NaOH plus hydrogen gas. Along with that, mercury is liberated. So this is the reaction in the central compartment. With the passage of time, the concentration of NaOH increases in the central compartment, and when it reaches to 99%, this process of electrolysis is stopped, and solution from the central compartment, it is taken out and is subjected to crystallization when we get the pellets of the sodium hydroxide, which are used in the different industrial and domestic purposes. Then we have properties and uses of NaOH. It is a totally white crystalline solid. Its melting point is 591 Kelvin. It is soluble in water. It is deliquescent. Deliquescent means it can absorb moisture from the atmosphere, and it is hygroscopic in nature, tendency to absorb moisture from the atmosphere. It reacts with carbon dioxide, produces sodium carbonate along with water. So it is uses of NaOH. It is used in the preparation of hard soaps, in the preparation of organic compounds. It is used in the preparation of artificial silk. It is used in the preparation of the cotton, mercerized cotton, and it is used in the cleavage reactions, and sodium ethyl alcohol mixture is used as a reducing agent. Then we have next question. Give preparation and uses of table salt. The salt which is lying on our dining table and is used in our diet. So what is the preparation of NaCl? NaCl is prepared from the seawater. The seawater is collected in the you can say the pits made around the sea banks. So this water is allowed to evaporate by taking solar energy. When water evaporates, it leaves behind the salts of the sea. They are NaCl, MgCl2, CaCl2, CaF2. There are a number of such salts. These salts are then collected from there, and they are now purified, vacuum evaporated in the industry, and are used in our diet. Mainly it contains sodium chloride, which is purified and distilled, vacuum evaporated to get pure salt. Now property of NaCl, it is water soluble crystalline substance. It is having melting point of 1074 Kelvin, boiling point is 1730 Kelvin, and its solubility is 36 gram per 100 gram of water. It is used for cooking purposes, and it is used in the leather tanning, and it is used as in the preparation of freezing mixture to freeze the ice cream material. Then we have in the preparation of NaOH and HCl and Cl2 gases, it is also used. Then we have what are the biological importance of sodium, potassium, magnesium and calcium ion. All of these ions, they are biologically important. For example, first of all, they play important role in the signal transmission. They transfer the nerve signal from the one part of the body to the brain. And then sodium and potassium ions, they maintain the concentration gradient along the cell membrane or cellular activities. For cellular activities, the concentration gradient of sodium and potassium ion is required, and they are used in the transportation of sugar, amino acids to the cell. Potassium ion present in large abundance in the cell fluid when they activate the large number of enzymes and number of cell reactions. Then they are also responsible for oxidation of glucose to provide ATP molecules, which are energy source to the body. calcium ions play important role in the formation of teeth and bones. Magnesium ions are responsible for food synthesis in the presence of, they are the important part of chlorophyll. They help in the photosynthesis by the plants, which convert carbon dioxide and water into carbohydrates. These carbohydrates, they act as energy sources to our body. Then we have the comment upon chemical properties of alkaline earth metal. We have already done this. All alkaline earth metals, they have the property, they can combine with oxygen to produce oxide. They combine with halogen to produce halides. They combine with water to produce alkalis. They combine with hydrogen, calcium, barium and magnesium. They form divalent hydride, CaH2, MgH2 and BaH2. And then hydrides of beryllium, they are polymeric in nature due to small size of beryllium and hydrogen. And then they react with acids to produce salts. They react with HCl to give halide. They react with sulfuric acid to give sulfate. They react with the nitric acid to give nitrates. And then how do the properties of their element, how do hydroxides of their element react with carbon dioxide? It is very simple. They are hydroxides. When they react with carbon dioxide, they produce carbonates. KOH twice combines with CO2 producing CaCO3 plus water. Similarly, we have BeCO3 combines with BOH twice. Combine with CO2 to give you BeCO3 plus water. This is OH twice. Magnesium hydroxide similarly produces magnesium carbonate. Then we have the question, what are the uses of beryllium, magnesium and calcium? Then we gave, they are used in the X-ray tubes. Beryllium is used in the X-ray tubes and it is used in the as a source of neutrons. When bombardment with the alpha particle is done on its nuclei, its compound find application in making computer parts. Then uses of magnesium, it is used in the metallurgical operations as a deoxidizer. It is used as a reducing agent in the preparation of Grignard reagent, which is a source of number of organic compounds. Uses of calcium, it is used as a reducing agent. It is used to remove sulfur from the petroleum, and then it is used to preparation of the vacuum apparatus. Then comment upon the basic characteristics of the oxides and hydroxides of alkaline earth metal. The hydroxides and oxides of alkaline earth metals, they are not so strong in the beginning. Beryllium oxide, beryllium hydroxide, they are weak bases. Due to small size of beryllium, it is not able to depart with oxygen. So they have less tendency, beryllium and magnesium, they have less tendency to produce OH ions. Beryllium has the very least tendency. Then as we move top to bottom, their hydroxides become capable of releasing the OH ion. That's why the basic character of the hydroxide increases when we move top to bottom. Then comment upon the halides of group 2 elements. All the halides of dihalides, they have general formula MCl2. The halides of beryllium, they are polymeric in nature. Due to small size of beryllium, it forms polymers. And bridge of chloride, they are stabilized between small size of beryllium atom. Then give the characteristics of sulfates of group 2 element. The sulfates of alkaline earth metals, they are quite stable. They do not decompose easily on heating, but they decompose at a very high temperature to produce metal oxide, sulfur dioxide and oxygen. So they are highly stable due to their high lattice energy, but at high temperature they decompose to give you MgO plus SO2 plus O2S. They break up at a very high temperature to give these compounds. Then comment upon carbonates, action of heat on carbonates and nitrates of these metals. Whether they are carbonates hydroxides or nitrates of these metals. When they are heated, they produce metal oxide, water, carbon dioxide along with that. So this is their action of heat on these compounds. Then give anomalous features of beryllium. We know beryllium has very small size. It has absence of vacant d orbital and it has high ionization energy. It has high polarizing power. Its oxide is bit amphoteric. It has high electronegativity and it has no vacant d orbital. It does not give color to the flame due to its small size and high ionization energy. So all of these properties they make a beryllium a very special element of group number 2. So this is all about lecture number 3.